Variable bit rate is a term used in telecommunications and computing that relates to the bit rate used in sound or video encoding. As opposed to constant bit rate, VBR files vary the amount of output data per time segment. VBR allows a higher bit rate to be allocated to the more complex segments of media files while less space is allocated to less complex segments. The average of these rates can be calculated to produce an average bit rate for the file. Opus, Vorbis, MP3, WMA and AAC audio files can optionally be encoded in VBR. Variable bit rate encoding is also commonly used on MPEG-2 video, MPEG-4 video, MPEG-4 10 per hour 264 video, Theora, Dirac and other video compression formats. Additionally, variable rate encoding is inherent in lossless compression schemes such as FLAC and Apple Lossless. Advantages and disadvantages of VBR. The advantages of VBR are that it produces a better quality-to-space ratio compared to a CBR file of the same data. The bits available are used more flexibly to encode the sound or video data more accurately, with fewer bits used in less demanding passages and more bits used in difficult-to-encode passages. The disadvantages are that it may take more time to encode, as the process is more complex, and that some hardware might not be compatible with VBR files. VBR may also pose problems during streaming when the instantaneous bit rate exceeds the data rate of the communications path. These problems can be avoided by limiting the instantaneous bit rate during encoding or by enlarging the playout buffer. Also, encryption of VBR encoded speech gives only limited privacy, as the patterns of variation of the bit rate may reveal what language is being spoken. In the past, many hardware and software players could not decode variable bit rate files properly, partly because the various VBR encoders used were not well developed. This resulted in common use of CBR over VBR for the sake of compatibility. As of December 2006, devices that support only CBR encoded files are largely obsolete, as the vast majority of modern portable music devices and software support VBR encoded files. Support for VBR in AAC and MP3 files is found in most modern digital audio players, including those released by Apple, Microsoft, Creative Technology, and SanDisk. Early VBR algorithms occasionally introduced audible artifacts when encoding monotone or minimal tones. These artifacts often mimicked a digital chirp during the quiet portions of the song or when there was only speaking. As VBR encoding algorithms have improved, these problems have been resolved in subsequent generations of the VBR standard. Methods of VBR encoding. Note that the choice of a variable bit rate method only affects the encoding process. Decoding a VBR stream is performed identically in all cases, regardless of how the encoder chooses to allocate bits. Multi-pass encoding and single-pass encoding equals, VBR is created using the so-called single-pass encoding or multi-pass encoding. Single-pass encoding analyzes and encodes the data on the fly, and it is also used in constant bitrate encoding. Single-pass encoding is used when the encoding speed is most important, for example for real-time encoding. Single-pass VBR encoding is usually controlled by the fixed quality setting or by the bit rate range or by the average bit rate setting. Multi-pass encoding is used when the encoding quality is most important. Multi-pass encoding cannot be used in real-time encoding, live broadcast or live streaming. Multi-pass encoding takes much longer than single-pass encoding, because every pass means one pass through the input data. Multi-pass encoding is used only for VBR encoding, because CBR encoding doesn't offer any flexibility to change the bit rate. The most common multi-pass encoding is two-pass encoding. In the first pass of two-pass encoding, the input data is being analyzed and the result is stored in a log file. In the second pass, the collected data from the first pass is used to achieve the best encoding quality. In a video encoding, two-pass encoding is usually controlled by the average bit rate setting or by the bit rate range setting or by the target video file size setting. Fixed quality equals, one means of VBR encoding is fixed quantizer or fixed quality encoding. it is usually single-pass encoding. The user specifies a given subjective quality value, and the encoder allocates bits as needed to achieve the given level of quality. This ensures the output stream will have consistent quality throughout. A quality level usually has an associated bit rate range. The disadvantage of this encoding method is that the average bit rate will not be known ahead of time, and achieving a certain average bit rate requires trial and error. This is typically more of a concern for video than for audio, since file sizes are much larger and encoding can take much longer. Bit rate range equals. This VBR encoding method allows the user to specify a bit rate range a minimum and/or maximum allowed bit rate. Some encoders extend this method with an average bit rate. The minimum and maximum allowed bit rate set bounds in which the bit rate may vary. The disadvantage of this method is that the average bit rate will not be known ahead of time. The bit rate range is also used in some fixed quality encoding methods, but usually without permission to change a particular bit rate. Average bit rate equals. Average bit rate encoding may be used to ensure the output stream achieves a predictable long-term average bit rate. This is typically implemented using multi-pass encoding, where one or more initial passes are used to collect data on the stream, and a final pass uses that data to achieve uniform quality at the specified average bit rate. Alternatively, periodic averaging may be used either by performing ABR on smaller chunks of the output, or by reacting to fluctuations in the ABR by increasing or reducing the overall quality. These can achieve ABR in a single pass, but do not produce the same degree of uniformity as multi-pass ABR. Some encoders use ABR encoding, and multi-pass encoding to refer to single and multi-pass ABR encoding respectively. Some encoders also allow the user to specify a maximum allowed bit rate or maximum quality value. This is sometimes called constrained variable bit rate, and is typically applied to ABR algorithms. The disadvantage of single-pass ABR encoding is the opposite of fixed quantizer VBR the size of the output is known ahead of time, but the resulting quality is unknown, although still better than CBR. Specifying a higher average or maximum may simply make the file bigger with no discernible quality effect, and an increased maximum bit rate may introduce stutter when streaming the file. However, reducing these criteria too low will eventually lead to quite drastic losses in quality. The effect on video is typically an increased blockiness, because the frames are no longer being fully detailed in their rendering. The multi-pass ABR encoding is more similar to fixed quantizer VBR, because a higher average will really increase the quality. There are no ideal one-size-fits-all settings for ABR in video encoding. For low-resolution video encoded with MPEG-1 or MPEG-2, the average bit rate can be as low as 1000 kbits and still achieve acceptable results. For a high-resolution video such as 1080, this average may need to be 6000 kbits or higher. The main factor in determining a minimum video bitrate is how efficiently the video can be encoded. Using more efficient video encoding such as MPEG-4 will help promote a lower bit rate, while significant amounts of motion or white noise will require a higher bit rate to encode without visible artifacts. In the end, the user may have to use trial and error to achieve a minimum file size for a given video stream, by encoding at a given bit rate and then viewing the results. File size equals, VBR encoding using the file size setting is usually multi-pass encoding. It allows the user to specify a specific target file size. In the first pass, the encoder analyzes the input file and automatically calculates possible bit rate range and/or average bit rate. In the last pass, the encoder distributes the available bits among the entire video to achieve uniform quality. See also, bit rate, average bit rate, constant bit rate, adaptive bit rate streaming. References